Today we're going to be learning about the Pythagorean theorem. To start off, we need to know the basic equation, which is a squared plus b squared is equal to c squared. Now let's start off with an example problem, right? I'm going to draw a little triangle over here, and I'm going to label this side 3, and I'm going to label this side 4. I'm going to label this side C. So first of all, what we want to do is we want to solve for side C because that's the length that we do not have. So I'm going to plug in 3 squared for A plus 4 squared for B is equal to C squared. 3 squared is 9 plus 16 squared is equal to C squared. 9 plus 16 is equal to 25 equals C squared. Now, we're not quite done yet. What we have to do is that we have to take the square root of C squared to get rid of the exponent of 2. And we're going to take the square root of one side and do it to the opposite side. So the square root of 25 is 5. It's equal to C. That is the basic steps in doing the Pythagorean theorem. Now let's try another example. It's always good to write the formula every time you start a Pythagorean problem or any problem because the formulas help you, writing the formula down helps you to memorize it. Just going to draw another triangle over here to start off with. We're going to label this side A. And we're going to label this side 13. And we're going to label this side 12. So now, the difference between the previous problem is that we are now given length C and length B, but not length A. So we're going to plug in everything that we have. B squared is 12 squared. And C squared is 13 squared. 13 squared. So A squared. Now we want to is equal plus 144 is equal to 169. Now basic algebra tells us to subtract 144 from both sides because we're solving for the variable A. So A squared is equal to 25. Now we're not quite done. We need to take the square root of A to get rid of the exponent of 2, so we just have A by itself. Take square root of both, and we're left with A is equal to 5. That's another way you can use the Pythagorean theorem to find out different lengths of the triangle. Let's do one more example. I'm going to draw a simple triangle right here. And I'm going to label this side root 5 or radical 5. I'm going to label this side 2. I'm going to label this B. A squared plus B squared is equal to C squared. Now let's plug in 2 squared for A. So 2 squared plus B squared is equal to root 5 squared. 2 squared is 4 plus B squared is equal to, well, now we've come to the fact that we got to square a radical, and we know that since when you square a radical, it's the function inverse, so they cancel each other out. So we're just left with 5. So we have B squared, B squared is equal to 1. What I did here was I subtracted the 4 from right here, and I subtracted 4 from here. So we have b squared is equal to 1, and we have to take the square root of each side. Take square roots. B is equal to square root of 1. We know that the square root of 1 is 1. And that's basically the Pythagorean theorem.